For months, astronomers believed they knew what they were dealing with: a frozen relic from another star, a visitor older than Earth drifting through our solar system for the first and only time. A comet, yes, but an interstellar one, rare beyond calculation. A cosmic messenger carrying chemistry from a different sun. But then something happened. Something so violent, so sudden, so unexplainable that even NASA hesitated to comment. Because according to the latest analysis from Harvard astrophysicist Avi Loeb, 3I Atlas, the third interstellar object ever discovered, may have undergone a catastrophic explosion, shattering into at least 16 separate fragments somewhere around perihelion. And the strangest part is this: the evidence doesn't look like a natural breakup. It looks structured, organized, almost controlled. This is the story of how an object born around another star system may have torn itself apart or activated right in front of us. And if the data is correct, we are about to witness something unprecedented in the history of modern astronomy: the real-time death or transformation of an interstellar traveler. Tonight, we're diving deep into NASA's numbers, Webb's infrared scans, Hubble's diameter limits, and the British Astronomical Association's shocking images to understand whether 3I Atlas truly fragmented, and whether the pattern of those fragments suggests something natural or something far stranger. Because once you see what astronomers captured in early November, you will never look at a comet the same way again. The story begins innocently. July 1, 2025. Chile's Atlas Survey telescope spots a faint object drifting into the inner solar system. At first, nothing seems unusual other than the fact that it's interstellar, only the third such object ever found after Oumuamua in 2017 and Borisov in 2019. But in late August, the James Webb Space Telescope captures something astonishing. Using the ultra-sensitive NIRS-SPEC instrument, Webb detects a colossal carbon dioxide gas coma stretching 348,000 km across, almost the distance from Earth to the Moon. At this stage, it looks like a typical, though unusually active, comet, except certain chemical ratios inside that coma aren't right. Iron and nickel appear in strange proportions. Molecules don't match expected patterns. Still, astronomers chalk it up to exotic interstellar chemistry. After all, this thing was born around another star. Maybe it's just different. Then September passes. October arrives, and as 3I Atlas drifts toward its closest approach to the Sun, the real anomalies begin. As Atlas nears perihelion, astronomers start noticing something deeply unsettling. The comet isn't slowing down under the Sun's gravity. It's speeding up. The Harvard tracked numbers show a radial acceleration of 1.1 times 10 astronomical units per day squared, and a transverse acceleration of 3.7 times 10 astronomical units per day squared, resulting in a cumulative increase of 94 km/day 2 at perihelion. To put that in perspective, the object was already moving at 150,000 mph, yet it somehow found more speed without any visible force acting on it. According to standard comet physics, the only explanation is outgassing. But if outgassing were the cause, Atlas must have been losing unimaginable amounts of material. And that is exactly what astronomers began calculating. Between early August and late October, the mass loss rate exploded from 330 kg/s to nearly 2 million kg/s, a factor of 6,000 times increase. This is where the alarms began to ring. This is where the math stopped making sense, because even for a comet under solar stress, this jump is absurd. Like a block of ice suddenly becoming a volcano, something was happening inside Atlas. Something building, something pressurizing. And then the comet began glowing blue, an unnatural color for outgassing dust. Nature does not glow blue unless something very specific and very hot is happening. Astronomers knew the moment of truth was coming. Here is where the entire cometary explanation collapses. At perihelion, the Sun delivered 700 joules per square meter per second to 3I Atlas. For the comet to sublimate enough ice to explain the mass loss rates, it would need a surface area of 617 square miles, the equivalent of a sphere 14.3 km across. But the Hubble Space Telescope imaged the object just 3 weeks after discovery, and its nucleus could be no larger than 1.2 km across. Not even close, 16 times too small, which means only one thing. Either the comet grew impossible, or it shattered. This is the exact moment Avi Loeb steps in. Loeb realizes something extraordinary. If 3I Atlas split into 16 fragments, each fragment would have its own surface area, and the combined surface area would match the required 14 km value exactly. The math is perfect, too perfect. 16 fragments equals 16 times the surface area, exactly the number needed to match the insane mass loss readings. This isn't guesswork. This isn't speculation. It's cold, hard astrophysics, published by Harvard's top theoretical researcher. And so, on November 10th, Loeb releases his analysis. 3I Atlas likely exploded into at least 16 pieces. But the Harvard paper introduces a darker question, one that scientists hate to ask. What if the breakup wasn't caused by the Sun, but by a mechanism inside the object? If a comet breaks into 16 pieces, we should see chaos, disorganized debris, random plumes, uneven gas clouds. But that's not what astronomers saw. On November 9th, British observers Michael Butner and Frank Nebling capture a set of photographs that change everything. These aren't amateur snapshots. These are high-precision, fully processed astronomical images. The pictures show an antitail pointing toward the Sun, two perfectly organized antitail jets stretching 950,000 km. A main collimated jet extending 2.85 million km. More structure than any natural comet should ever produce. This is not random. This is geometry. This is directional organization. The very next day, astronomers Yeager, Riemann, and Prosperberry capture at least 7 distinct jets, all aligned in a coordinated pattern. Natural fragmentation looks messy. This looks engineered. Loeb calculates that the comet is shedding 50 billion tons per month, yet the fragments remain coherent. Something is driving these jets, and it is not passive ice sublimation. Astronomers try to push back. Comets fragment. We've seen it before. Yes, Comet 73P Watchman did it. Yes, Comet NEOWISC behaved strangely, but fragmentation always has fingerprints. Internal temperature rise, crack propagation, uneven mass ejection, diffuse hazy debris, chaotic jets in random directions. 3I Atlas displays none of these, not with us in mind but seen by us all the same. And now, as it drifts away into the black, the only thing we are certain of is this: we will never see it again. This was our one chance, our one moment, to witness a visitor from beyond, to study it, to understand it, to listen to what it had to say. And whatever message it carried, whatever truth it encoded in its motion and its silence, it is now scattered across the void in 16 silent pieces. If this story left you wondering what else is hiding in the darkness between the stars, don't let that curiosity fade. Subscribe to the channel because this is only the beginning of what astronomers will uncover in the coming weeks. Turn on notifications. Updates on the 16 fragments will arrive any day now, and you'll want to know the moment they do. And tell us in the comments, do you think 3I Atlas broke apart naturally, or did we just witness the activation of an interstellar mechanism older than Earth itself?